Okay, gang, welcome back. I'm very confident that we're going to complete these notes within this next video here. So what we were doing was we were trying to find the tangent of this 3/4 pi angle, which is right here. The tangent of 3/4. Well, the tangent is y over x. Y over x. So what is y over x? Well, it's rad 2 over 2 is your y, and negative rad 2 over 2 is your x. And you might have to do some of this on the side of your paper because this just gets really messy. So, or just watch, or I don't know how you want to do it. But that's -1. The tangent of 3/4 pi is -1. So I can put -1 in there. What is the tangent of 2/3 pi? What's the tangent of 2/3 pi right there? Well, the tangent of 2/3 pi is also y over x, and that is rad 3 over 2 over -1/2. Okay, y over x. I'm getting the tangent of 2/3 pi, which is right here, and I had to take y over x. Well, this is the same thing as multiplying by the reciprocal, so it's like multiplying by -2 over 1, and your 2's cancel, and it looks to me like this would just be negative rad 3 over 1, but you don't have to put the over 1 part. So negative rad 3 is the numerator, and the denominator would be just the 1 that we have here. Got a pesky minus sign that we have to be vigilant about, and we already found the tangent of the 3/4 pi angle. We already found it. It's -1. So it's 1 minus -1 times, and we've already found the tangent of 2/3 pi as well. That is negative rad 3. Woo! Well, what is this mess? Is this our answer? Is this, how can we, I think we need to clean up a little bit here. The top, I guess we can just leave as -1 plus, or what, actually just put minus rad 3. How about that? -1 minus rad 3. The bottom is where you have to be careful. This is 1. Okay, negative times negative is positive, right? That would be rad 3. So that's positive, but it's 1 minus all that. So it's really 1 minus rad 3. And I really wish I could say that was our final answer. I'm almost ready to box it in, but we can't quite do that because we have an illegal denominator here. We have an illegal denominator that has a radical. I really would even want to do, like, start canceling these, but you can't do that because they're attached by negative signs. What we did about 3 months ago was whenever we had a radical in a denominator that was part of a binomial, remember what we could multiply by, and it always gave us it always took care of this every time. It was abbreviated CC. It was actually CC, complex, what was it? The complex, it's actually not complex because we don't have an I in it, but we could multiply by the conjugate. We could multiply by the conjugate, which is the same numbers, just the different sign in the middle. If I multiplied the bottom by 1 plus radical 3, now of course I have to do that to the top as well to pay the price. This will take care of my illegal denominator situation. So let's do that. Hope you have some semblance of room, and we just have to FOIL. We have to FOIL. Crazy foiling situation here. So -1 times +1 is just -1. -1 times radical 3 is negative radical 3. And the inner, the I of FOIL, is negative radical 3 times 1. That's another negative radical 3. And look at this, last times last. That's negative rad 3 times positive rad 3. Is that not negative radical 9, which is actually a -3? Yeah, because the square root of 9 is 3. So what we're looking at in the numerator anyway is, I'll give you a couple seconds to catch up there. I'll just go ahead and kind of clean up my numerator here. We're looking at, it looks like we're looking at there's a couple of rad 3's, but they're negative. So that's negative 2 rad 3. And then you got a negative 1 and a negative 3. That's negative 4. My denominator, remember, with conjugates, all you have to do is multiply the first and the last because the middle terms cancel out. So 1 times 1 is 1. Negative rad 3 times positive rad 3, again, is negative rad 9 or negative 3. And so 1 minus 3 is negative 2. We are so close to being finished, but I just see too many even numbers, and I know something can be cleaned up. In fact, if I could pop a negative 2 out of this top, it would for sure cancel with the bottom. Remember, you can't cancel these negative 2's right now because this whole entity is attached by a negative sign. And so that's really a fake negative 2. Can't really cancel it out. But if I factored out a negative 2 from that top part, that would leave me with rad 3 plus 2, right? Remember, factoring is a lot like dividing. And then I have that negative 2 on the bottom. Well, look here. Look here. Ba-ba-bam. Final answer of this beastly problem is rad 3 plus 2. What a problem. What a problem. Man, so that was something else there. And I'm still on the unit circle here. I don't even know if that would have all fit into your notes here. Where are we at? Maybe so. Look at that. Look at that. Might have fit, except you had to go over into this part here. But yeah, so the tangent of 17/12 pi is actually equivalent to radical 3 plus 2. Man, for the sake of time, I'm going to cruise right on to our final our final example here, and I guarantee you it's not as bad as what we just did. You're just going to reverse the process now. You're going to start with a sum or a difference identity, and you're just going to backtrack and tell me what it was, what did it look like at the start. And so if you look at this first one here, and I just say reverse it, it says find the exact value of each expression. So what is the exact value of the cosine of 7/8 pi times the cosine of 5/24 pi plus the sine of 7/8 pi plus the sine of 5/4 pi, or 5/24 pi? Well, which does this match up with? Which identity does this match up with? I mean, we have what? We have the cosine. It's cosine, cosine, sine, sine with a plus sign in between. Well, that is right here. It's cosine, cosine, sine, sine. So we're actually starting with this and moving backwards and writing it as this. And it's actually not too bad because alpha is just your first degree, your angle measure, and beta is your second degree. So I'm going to write this as the cosine of 7/8 pi minus 5/4 pi. It's going to go backwards. So this would be equal to the cosine of 7/8 pi minus 5/24 pi. See, what we did up above was we started with this in blue and went to this. Well, now we're going the reverse way. We're starting with a big old sum identity and backtracking. And then all you have to do is just go ahead and get a common denominator inside here and add these together. The common denominator would be 24, right? That'd be 21/24. 21/24. And subtract 5/24. 21/24 minus 5/24 is 16 pi over 24. 16 pi over 24. That is reducible. Those are both reducible and divisible by 8. And so that would be a 2 and a 3. And so I am looking for the cosine of 2 pi over 3. What is the cosine of 2 pi over 3? I think we've already referenced it earlier today. The cosine of 2/3 pi. The cosine of 2/3 pi is right there. Looks to me like it's -1/2. The x-coordinate of 2 pi over 3 is right where my cursor is circling. It's negative 1/2. So that would be your answer. Your answer is negative 1/2. We found the exact value of all that stuff that we started with here. Where's it at? Yeah, can you believe all that is equal to negative 1/2? That's kind of amazing. Well, if you want to stop the video and try B, you can. I'll go ahead and do it, but stop it now if you want to. All right, welcome back. If you tried this one, let's see how you did. Let's see, this is a difference identity for tangent. And so you would go back up and look at the difference identity for tangent, and you're just going to go backwards. We have one angle, angle alpha is 78, angle beta is 18. So we're going to reverse this baby. This would be the same thing as the tangent of 78 degrees. And it's a minus, and so we actually use a minus because tangent is the same sign. If you're using a minus, it's minus. If you're using a plus, it's plus. So 78 degrees minus 18 degrees, and that is simply the tangent of 60 degrees. So go back up on your unit circle, and remember, tangent is y divided by x. So what is y divided by x of a 60-degree angle? And I can tell you right now that that is going to be 60 degrees is right up here. And I got to take, it looks like I have to take rad 3 over 2 divided by 1/2. Rad 3 over 2 divided by 1/2. But I bet some of you are getting good at doing this in your head. And I bet you can actually do rad 3 over 2 divided by 1/2. You take the reciprocal, your 2's cancel out, and you just end up with rad 3, don't you? So those are the section 5.4 notes. And I have really tried to set you up nicely to conquer some problems on this assignment. So I want you to try numbers 1, 3, and 6. That's a sine identity, a cosine identity, and a tangent identity, just like our example 1 above. And then I want you to try 3 problems that reverse it. So 11, 13, and 15. I would definitely check your odd answers in the back of the book. Make sure it's going well. Good luck. I hope these videos helped.